All right, we get to venture into chapter 4. Chapter 4. Your tests have been regraded and they're posted. I'll get them back to you eventually. I'm going to screencastify until Evelyn comes back. She had surgery last week, so we'll screencastify. And I won't webcam it. I'll keep the mic there though. On the count of 3, let's say hi, Evelyn. Okay. 1, 2, 3. Hi, Evelyn. Hope you're doing better. All right, we're going to start into chapter 4. Chapter 4 starts dealing with forces. May the force be with you. By definition, we have a force is an action exerted on an object that may change the object's state of rest or motion. It's an action that's exerted on an object that may change the object's state of rest or motion. We will have a football analogy here. You have 2 linemen, offensive, defensive linemen. The center hikes the ball to the quarterback. Both sets of linemen go at it. Now, a bunch of things could happen at this point. Okay, they can go at it and basically have a stalemate. Okay, so they both stand, they both interlock, they're both holding on to each other because we know holding never happens on every play. They're holding underneath their shoulder pads, but they're not moving anywhere. They're not going in either direction. So they're exerting a force, they're pushing against each other, but they're not going anywhere. Or you can have the other scenario where Myles Garrett starts going in the interlock, and the next thing you know, the guy is looking at like Al Roker checking out the stars and the skies and the cloud because he's looking up as Myles Garrett runs over top of him. Okay? Or we can have the other side where Grayson is blocking on the offensive side, and he's pushing, and the defensive person is running in retreat over there. Okay? They're running in retreat. So when we talk about force, you got 2 things being forced against each other. You could have a stalemate, and you could just be locked in. Okay? And they're just standing there. If they're standing there and not moving either way, they might as well just stop and just stand there and look at each other. Because they're not going anywhere. So you have nothing in result of both of these 2 people blocking. If they're both blocking and they're not moving either direction, just stop. Just stand there. Hey, how you doing? Start talking about Pythagoras. Okay? Start talking Pythagoras to him a little bit. Or talking about the forces that we'll talk about today. Okay, well, you can start talking to them about inertia, which we'll talk about here in a little bit. Okay? Or one could be going over top of the other. So that's the idea of force. You may or may not change a state of motion. Units for force. They're named after Sir Fig of Isaac Newton. They are your newtons. Okay, strawberry, date, fig newtons. Strawberries are pretty good. Strawberry newtons. Even though they're not, in essence, the idea of a newton, you got that strawberry flavor in there. That ain't bad. That ain't bad at all. They are newtons. We abbreviate newtons with a big N. Or Sir Fig of Isaac Newton. Definition or meaning of force. It's the amount of force required to accelerate 1 kilogram object 1 meter per second squared. They used to have a mass in there, 1 kilogram. We'll use this. Suppose this we have a mass of 1 kilogram. When you're looking at a newton, we are accelerating this mass 1 meter per second squared. Or we are increasing the velocity from 0 meters per second to 1 meter per second in 1 second. You want to think of it that way. We are accelerating a mass of 1 kilogram from 0 meters per second to 1 meter per second in 1 second. Good enough. So if this object, 1 kilogram, this 1 kilogram object, I'm speeding it up to 1 meter per second in this 1 meter. Okay, or in 1. In that 1 second, I go from 0 to 1 meter per second. So we got 1,001. Okay, 1,001. And I go 1 meter per second in 1 second. Okay, the amount of force required to move this 1 kilogram up to from 0 to 1 meter per second in that 1 second, that is a newton. Okay, that's the idea of a newton. Accelerating 1 kilogram, 1 meter per second squared, or from 0 to 1 meter per second in 1 second. That is your idea of a newton. Okay, when we're dealing with newtons, that's the essence of what we're trying to do. You're trying to accelerate an object, and how much effort does it take for me to accelerate that object? That's the force. When you're pushing against something, you have to exert a force. Okay? It just doesn't magically move by just staring at it and using my mental telepathy here to say move, okay, you have to push it. Very similar to, I've just gone through 4 weeks of dealing with leaves in my backyard, in my front yard. As I rake them onto a tarp, and I have to move from my backyard up to, or my front yard, back to a ravine in my backyard, which is just below the practice football field. I put the leaves on the tarp. I cannot just stand there and look at them and say, move. And they will automatically move for me. I have to roll up like Santa or a taco, fold over the two corners, put it on over my shoulder, and drag the leaves back into the ravine. I have to exert a force. I always tell my cardiologist or my doctor, that's my stress test for my heart. If I can pass that in the fall, my heart, I think, is good enough. The only problem is, if I fail my stress test, that's probably not a very good situation at that point. That means my heart blew up. Not a good thing. If you fail your stress test, that's not good. Being in the medical office, that ain't as bad. They got defibs. They can hook you up. The squirrels aren't going to go run and grab a defibrillator for me and go hook it up. Upper right, lower left, and hit the button and say clear. Okay, they're not going to do that. So hopefully I never get to that point. Contact force. When we talk about a contact force, a force that requires interaction of two objects to change the object's state of rest or motion. You have an interaction between the two objects. You have some interaction. The two football players, there is interaction. There is a contact force that is occurring, that is forcing one object to move one way or another, or basically stand still. Me dragging leaves back, there is a contact force there. The second is a field force. It's a force that's utilized, does not utilize physical contact. It's a force that is not utilize physical contact to change the object's state of rest or motion. This is a field force. We have two objects here. Two objects. I'm going to put one in the other, and magically, the one moves to the other. It moved. It's magic. Okay? There's no physical contact between these two objects to make it move, but it still moves. Well, what we have is what is called a field force. Magnets, you talk about a magnetic field, that You don't have contact here, but the objects still move, okay? If there's movement, there has to be a force that pushes one into the other, just like two football players, okay? You have contact, you're going to move in one direction or the other. If you had tug of war, okay? We had a tug of war between this side and this side over here. We put the little ribbon in the middle, we have the rope here, they start tugging, all of a sudden the ribbon starts moving in this direction. Because these people are studs over here. Okay? It's going to start moving in that direction. So you guys have nothing over there. Okay? You have movement there. Okay? Change the state of rest or motion. You have the ball. That's right here. If I let it go, it moves towards the ground. There was nothing that I saw. I did not throw it down. I didn't see a rope that was tied to it. I didn't see the magic claw come up here and pull it down. The claw. But it magically went from here down to here. If you stand on a chair and you take a step off the chair, you're going to go to the ground. Hopefully you take both feet off the chair. Because if you just take one off the chair and it's rather high, you're going to tumble down the road or down the floor. Okay? All those are field forces. So when you deal with magnets, or gravity, those are field forces. And some people will say that gravity is a magnetic force. Okay, it is a magnetic force that's occurring there. You have, if you ever get into the engineering world and you get into this aspect of it, you accelerate protons, you accelerate neutrons or electrons when you try to accelerate them. How do those accelerate? They are done magnetically. Okay, so things happen magnetically to be able to accelerate things to very, very fast speeds. Force is a vector quantity. Victor? It requires a magnitude and it also requires a direction. You have a magnitude and you have a direction. The magnitude is the quantity of force that's applied to an object. The quantity of force applied to an object. We have a magnitude, we'll have a net force, because you're going to have quantities. If we have a tug of war, you're pulling in that direction, you're pulling in this direction, you're both applying forces. Okay, because you're trying to make something move. If you have football players, once again in contact, okay, they are pushing against each other. The magnitude of what they're pushing against each other will eventually result in a net force. In 1630, Galileo Galilei stated an object's nature is to maintain the same state of rest or motion. That's all he said. An object's nature is to maintain the same state of motion. if you're out in space, or you watch astronauts out in space, and they do a spacewalk, and if they would get shoved, and they don't have any ropes tied to them, if they would get shoved out in space, would they ever stop? The only time they would stop is when they ran into something. If they ran into something, they would stop. But if they don't run into anything, they're just going to keep on going. They're going to have the nature of maintaining the same state of rest or motion. Well, that led to Newton's first law of motion. An object at rest and an object in motion continue in constant velocity, that means constant speed in a straight line, unless the object experiences a net external force. An object at rest and an object in motion continues with a constant velocity, that is, constant speed in a straight line, unless the object experiences a net external force. That astronaut that gets pushed out in space will maintain that velocity forever until he runs into something. If you could shoot a bullet or a cannonball fast enough from the highest peak in the world at a high velocity, and it continues at a velocity, it will continue at that velocity, and as it curves around the Earth, it will continue at that velocity, even though it's not a linear motion, it's local linearity. But this is Newton's first law of motion. Object at rest and object in motion continues at a constant velocity. A net force. It's the sum of the forces acting upon a body. The sum of the forces acting on a body. And then one of my most favorite words of science is the word inertia. You have to get a little nasally when you say it. You get nasal going there. Inertia. It's a tendency of an object to resist being moved, or if the object is moving, to resist change in motion or speed or direction. The tendency of an object to resist being moved, or if the object is moving, to resist change of speed or direction. That is the idea of inertia. Inertia is what you battle every morning. Because every morning that alarm clock goes off, we hit the snooze button or we hit the off button. But it is very, very difficult to get out of the horizontal position into a vertical position. You are fighting inertia there because you are resisting the change of what you have, which is a change of rest. So every morning when you get up, you're battling inertia. We all fight it. We all resist that change in motion or change in rest into motion. We will stop there today because we're almost done with the class. We'll talk about net forces on Monday. We'll go on the back side here and deal with some more stuff. All right, questions you have?